Okay, so this first lesson is from chapter 12, 12.1 on the three-dimensional coordinate system. So, um, so the ideas uh, we're used to graphing in 2 dimensions, and now we're going to extend that to 3. Okay, so let's see. Well, okay. So uh, let's go ahead and go through it. So in 2 dimensions, you have an x-axis, a y-axis, and a z-axis. And so in 3 dimensions, the z-axis goes up and the x-axis goes out at you, toward you, and the y-axis is to the right. And so then every point in 3 dimensions has a coordinate X, Y, Z. So you go over the axis first, then the Y axis, and then the Z axis. Okay. So now one of the ways that you can remember this is they have what they call the right hand rule. And so you imagine if you start with the X and you are kind of sweeping around to the Y axis, the Z axis goes up. Your thumb is pointed up. And so that's what that means. Okay. So you have each plane is a flat surface where uh, it's like the Cartesian plane that we're used to. So like the XY plane, the YZ plane, the YX plane. So like for the YZ plane, for example, excuse me, the XZ plane, the Y is 0. So that's just a flat surface. And so if you can imagine if you hold one of the variables constant and then the other two could be anything. And so you'd have a point in that plane. All right. So these different planes actually divide the space into 8 octants. So in the Cartesian plane, we have quadrants, the 4 regions, but now you actually have 8 different 3-dimensional regions, so octants. So if you have, like, let's say here's the line y equals 3. Okay, so here's y-axis, y equals 3 up here, z equals 5. So that's like the blue plane, z equals 5. So you can see where they intersect. And so x equals 2. So if you imagine, here's the x-axis, and then if you move over to 2, then see you're going to get this plane right here. So when you're trying to find a point, let's say 2, 3, 5, you start measuring over in the x direction. So here's 2. Okay. So here's 2, 0, 0. All right. And then the y direction would be over 3. So in the 3, 1, 2, 3. And then the z direction, we would go up 5. So up 5. So here's the 0.235. So it's like it's out 2, and then over 3, and then up 5. Okay, so it says we can interpret these equations and inequalities geometrically. So we can have planes, we can have lines, we can have points, we can have different kinds of curves. So just like in 2-dimensional space, we have certain shapes. In 3-dimensional space, we have other shapes. Okay. So let's look at some examples. Okay, so let's see if this is going to load up. Okay, so we have equations and inequalities over here, and then what their description is over here. So the idea is if we plug one into here and into here, you can see what they match, how they match up, okay? So what I'm going to do is like, so this would be -1 is less than y is less than 1. So if we put that over here in the guy's shield, right, so that would be the space between those two planes. Okay, let's see. I wonder if I can make this a little bit bigger. Let's try. Okay. All right, so then we're going to look at which of these it would match. So let's see, the half space consisting of the points above the XY plane. Well, no, we want the ones between -1 and 1. Okay, so let's see, -1 and 1. Okay, the slab between the planes Y1 and equals -1. Okay, so let's try that. All right. So we put that together as a match. So what we do is we check them at the end and see if they work. Okay. So let's try the next one. Okay, y equals 2 and z equals y equals -2 and z equals 2. Okay. All right. The line in which the planes y equals -2 and z equals 2 intersect. All right, let's try that. Okay. All right, x is greater than 0, y is greater than 0, z is greater than 0. So they're all positive. So that would be the very first octet. All right, and next, x equals -3. Let's see what would describe that. X equals -3. The line perpendicular to the x-axis at x equals -3. The plane lies parallel to the YZ plane and 3. All right, so let's try that. Okay, we're going to test all of these here at the end. Okay, so z equals 0. So that's a plane. And then x is negative, y is going to be positive. So the half space, let's see, on the second quadrant, no. The half space consisting of the points above the xy plane. Z equals 0. I'm not sure about that, but let's test it. Let's see if that, the last one. Okay, z is greater than 0. So z is positive. Second quadrant of the XY plane. That wouldn't be a quadrant, that would be the whole thing. I wonder if that last one, let's see, can we change that to half? Let's see. Oh, it's not going to let me switch those around. Okay, we're probably going to get fried on those last two. Because the second quadrant, that's going to be where z is positive. Well, the z is where x is negative, y is positive, 0, 0. Okay, let's just check and see what we've got here. I'm going to check the matches, see if we get burned. Oh, yeah, see, we got burned because of those last two. So let's switch those around. Let's see what let me. Well, okay. So we just need to switch those two around. I knew there was a problem when I got to that last one. All right, so Cartesian coordinates x, y, and z of a point P in space are the values at which the planes through P perpendicular cut the axis. So that's how we find the particular points. All right, so what points x, y, and z satisfy the equations x squared plus y squared equals 4 and z equals 3? Well, so if you imagine see x squared plus y squared equals 4, that's a circle. Z equals 3, that's going to be a plane. And so where they intersect, that's just going to be a plane. That's going to be where the circle on the plane, where the circle and the plane intersect. So it's like the top part of a cylinder. All right. What points x, y, and z satisfy the equations x equals -1 and z equals 1? So if x equals -1 and z equals 0, then you can imagine like this point would satisfy it, and this point, and this point. And so would be the other ones? Well, it would be all of them. At any point that would have a -1 in the x as an x coordinate and 0 as a y in the z coordinate would work. You could have any number you want here. Okay. All right, next, the distance formula. The distance formula this is how to find the distance between two points in space. And so this distance formula, it kind of looks like the Pythagorean theorem, and it's like the three-dimensional version of the Pythagorean theorem. So we take the difference in the x's squared, plus the difference in the y's squared, plus the difference in the z's squared, and then take the square root. And that'll give us the distance or the absolute value between those points, or magnitude, or however you want to say it. So it's like the three-dimensional version of the distance formula based on the Pythagorean theorem. So if I want to know the distance between the points, let's see. I'm still zoomed in. That's the problem. Okay, between these 2 points. So then what I would do is just plug those into the formula. The distance, the square root of the difference of the x squared plus the difference in the y's. And see, you could go 1 minus 3 squared or 3 minus 1 squared. It really doesn't matter because you're going to square it. And then 5 minus 0 or 0 minus 5 squared. And so you can just put that in your calculator and just crank it out. And you could either simplify the radical, 3 radical 5, or give me a decimal. Decimal's just fine. Now, I didn't really talk about this, but before you really start working through these lessons, you really should have downloaded the Student Success Organizer to help you with the vocabulary, to help you know the notes you need to take. And they also have the different practice problems, or it's for you to write down notes, like on the matching game, or like on this next one. Okay, so typically what I would like you to do is on the video, when you come to a practice problem, it's already written down on your paper. And so just pause the videotape now and try to pause the lesson and then work it out, and then we'll check it out. So go ahead and pause. Okay, so just going through the answer, you take and you're using the distance formula. Okay, so it's the difference in the x's. So 1 minus 4 is 3 squared plus the difference in the y's, 4 minus a negative 2. So that's 6 squared, which is 36. And then the difference in the z's, 5 minus 7 is negative 2 or positive 2, depending on if you went the other way. And then when you square it, you get 4. So this gives you the square root of 49, which is 7. So the distance between those 2 points is exactly 7 units. Okay, so here we have a point in space. And if we say, okay, we want all the points that are a certain distance, A, from that point, then that makes a sphere. So it's just like a circle in 2 dimensions is the set of all points at a certain distance. A sphere is the set of all points that are a certain distance in 3 dimensions. All right, so it says the standard equation for the sphere of radius A and center x sub 0, y sub 0, z sub 0. So the formula is x minus x sub 0 squared plus y minus sub 0 squared plus z minus z sub 0 squared equals a squared. And that's similar to the formula for a circle in 2 dimensions. We use like an h and a k in trig in college algebra. So the variables are a little bit different. We're using x sub 0 and y sub 0. In R or A, it's the same thing. All right, so find the sphere and the center and the radius of this sphere. What we need to do is put it into standard form. So we need to get the x's together, the y's together, and the z's together, and complete the square for each of those to put it in standard form. Okay, so let's get the x's together. So x squared plus 3x. Get the y's together, y squared, and there's no other y terms, so just y squared. And then z squared minus 4z, we get those together. And then any constants here, like the 1, we just move it to the other side to get it out of the way. Now we're going to complete the square 3 times. So here, half the middle term, half of 3 is 3 halves. So we square that and we get 3 halves squared, or 9/4. There's really nothing in here in the y's to complete the square, so you can leave that alone. Half of this middle term is negative 2. Negative 2 squared is 4, so we can add that. And then whatever we add in here to complete the square, we have to add to the other side. So then we have x plus 3 halves squared. It's always half the middle term before you square it, goes inside here. And then we didn't do anything with the y's. And then half the middle term here is negative 2 squared. And now we add negative 1 plus 9/4 plus negative 2 squared is 4. We get 21/4. So that makes our center at, okay, so the opposite of the number is negative 3 halves. So that's our x sub 0. The y, there's nothing with that. So the y sub 0 is 0. And then the z sub 0 is 2. And so negative 3 halves, 0, 2 is the center. And then 21/4, if we take the square root of that, that's the square root of 21/4 is the square root of 21 over 2, because the square root of 4 is 2. And so then that gives us a final of the center is at negative 3 halves, 0, 2. And the radius is radical 21 over 2, or you could write it as a decimal. You could just, what's the square root of 21/4, and do it that way. Okay. All right. So go ahead and pause and see if you can work this one out. Find the center and the radius of the sphere x squared plus y squared plus z squared plus 4x minus 4z equals 0. All right. So getting the x's together and the y's together and the z's together. To get the square with the x's, we've got to add 4. So we add 4 over here. We don't have to mess with the y's. To complete the square with the z's, we also have to add 4. And so then that's going to get us x plus 2 squared plus y squared, z minus 2 squared equals 8. So that gives us our x sub 0 is -2, y sub 0 is 0, z sub 0 is 2, and then a is the square root of 8, or 2 radical 2. Okay, so then that's the center, and this is the radius. All right, we have our other little knight versus the dragons game. Okay, so this is to, again, with the geometric parametrizations. So this is example and practice, because we kind of would do these together in class normally. So we start off with x, well, this is kind of hard to read. X squared plus y squared plus z squared is less than 4. So here, there, x squared plus y squared plus z squared equals 4 would be a sphere. And so if we want less than, then we were talking about the interior of the sphere, what's inside there, right? Next, x squared plus y squared plus z squared. Wait, x squared plus y squared plus z squared. Isn't that the same thing? X squared. What am I missing here? Somehow that's actually messed up. Let's go to the next one. Okay, x squared plus y squared plus z squared is greater than 4. Z is less than 0. So that would be outside the exterior of the hemisphere, but since z is less than 0, that would be the lower hemisphere. All right, and then we have x squared plus y squared plus z squared is greater than 4. So if it's greater than, that's outside the sphere. So that would be the exterior of the sphere. Oh, okay, so this solid ball, that means it's got to be less than or equal to. So one of these should be or equal to. Let's just see if it's this one. All right, let's check our matches. See, we got them all right that time. Okay. So we need to reset. Let's see, we'll reset. And then this last one should be or equal to. Let's see if I can switch that really fast. Oh, let's see, it's over here. Well, I'll add in an equal and See if that helps. Yeah, it's not much better, but at least it's a little more accurate this time. So again, if it's equal to, like here, x squared plus y squared equals 4, that would be a circle of radius 2. X squared plus y squared is less than 4, that would be on the interior. X squared plus y squared plus z squared equals 4 would be right on the sphere. If it's less than 4, then it would be on the interior. If you had, so this is the sphere, if it's between 9 and 4, then it would be part of the shape outside of the smaller sphere and inside the bigger sphere. Okay. All right, well, that's it for section 2.1. So again, what I would suggest that you do is after you've gone through the guided notes and watched the video, then the next thing you do is try some of the problems, some of the odd problems that you can check in the back of the book. Focus on the ones that are the more similar to the practice problems. And then when you feel ready, then take the quiz on 12.1. You got to take it twice. So if there's something that you miss, then that's definitely one that you want to go to tutor.com or the MPC tutor. If you ask me a question, like let's say you're still don't understand and you want some from me, I won't discuss an exact quiz or test problem with you, but one similar to it. So you could, change the numbers a little bit and we'll work through it. Or like if you see, oh, that's similar to number 5, then we'll do that one. And so then once you feel comfortable, then take the quiz the second time and you'll get your highest score. Okay. All right. Well, good luck and we'll see you next time.